Today we're solving quadratic equations in a way that's a little bit easier. So here's the main concept we're going to be covering. If you have some sort of quadratic equation that looks like this, in the form ax squared minus c equals 0, well then it can be solved simply by using SADMAP rules. Here's my example. If I have something like 2x squared minus 98 equals 0, yes, I could factor it and then I could solve by factoring, but the easier way to do this problem in this case is to simply add 98 on both sides, following the subtraction addition. Then I do my division multiplication, I divide both sides by 2. Square rooting something counts as an exponent because, as we remember, this radical sign is another way of writing something to the 1/2 power. Because we're in algebra now and we're soon going to start talking about imaginary numbers, when we take the square root of 49, asking ourselves what number, when multiplied by itself, equals 49, we say, oh, well that could be positive 7, but it could also be negative 7. So we write x equals plus or minus 7. Our next example shows what we do if we have an equation inside something being squared. Again, what we could do is rewrite it by subtracting 25 and then factoring, but that would be really nasty and I don't feel like doing that. So what we're going to do instead is go back to our SADMAP rules. Stuff in parentheses is saved for the very end. So for now we can say we have a chunk squared, which we see there's no subtraction addition, there's no division multiplication affecting this chunk. The only thing that's happening to the chunk is it's being squared. So we immediately just go ahead and take the square root. What happens when we do this, though, is we get two equations. So let me show you what I mean by that. When I take the square root of both sides and I eliminate this here, I'm going to get this. 2x plus 3 is equal to plus or minus 5. But we're not done solving yet, because this gets split into two equations. Because 2x plus 3 could equal positive 5 and 2x plus 3 could equal negative 5, we make two equations, and we simply solve both of them. If I wanted to check my answers, I definitely could. I would go ahead and I would take both of these answers that I got and I would plug them back into the equation and see if it equals 25. So let's go ahead and do that. I'm just going to check positive 1. So I'll say to myself, does 2 times 1 plus 3 squared equal 25? And I'll see that 2 plus 3 squared equals 25. 25 equals 25. And that's how I checked and made sure that I did my answer correctly. If I did the same thing with negative 4, I would get the same thing. I would get 25 equals 25. Let's say for the sake of argument, I have a really gross equation like this, and I want to go ahead and solve it. Again, I would just use SADMAP rules, except this time I see that this whole chunk that's being squared, which is in the parentheses, which means it's saved for later, it's being subtracted by 8. So I would go ahead and eliminate it like this. Then I could square root both sides, therefore eliminating the square, and I would get 4x plus 3 is equal to the positive or negative square root of 10. Because we don't know what the square root of 10 is, we just leave it like this, but we also have to remember the number could be positive or negative. We're not going to go ahead and do this on our calculators, though you could. We're actually just going to go ahead and simplify it just like it is. So here when I divide both sides by 4, I make sure that I have this entire thing, the entire expression on the right side gets divided by 4. And I just leave it, I could leave it with parentheses, I could take the parentheses off if I wanted to, as long as the entire thing is being divided by 4. So when I do this, I write my final answer as x equals negative 3 plus or minus the square root of 10 all over 4.